The shape of meniscus of a liquid of zero angle of contact is. Come on, go to the basics, right? See, I am telling all of you, just go to the basics, think properly and solve this problem. See, don't sit in this, so don't try to think that, oh, I got 90%, 95% in my 10th standard, I am very brilliant. Oh, okay, then I know a lot of science, I have solved IIT problems, I will solve. Don't sit with this ahankar. Just be calm and cool and say, well, there is something here, I will use science and get the answer. Then you will definitely get the answer. Go to the basic approach and solve. Don't start hunting for any formulas and all. That's not will help your cause. Basics. Basics given in NCERT textbook is sufficient.
Sir, is there no consistent?
Why?
Sir, when we know that angle of contact is measured from the surface of the tube to inside the liquid, sir, inside the liquid surface. So, hemisphere is the only shape where the angle of contact will be 0.
Why?
Then it will be 90 degrees. For parabola, it will be more than 0.
No. Oh, I didn't get you. What are the science behind your answer? You didn't tell me clearly.
The angle of contact will be measured inside the liquid, sir.
Angle of contact will be measured inside the liquid. Fine.
From the liquid surface to the surface of the container.
Container.
If you are getting meniscus means capillary tube or some other, this thing should be there, no sir, in which you are pouring the liquid. So between that and inside the liquid, that will be the angle, sir.
Okay, let me do
we draw the diagram.
Wait, you tell me. So I draw a tube, right?
Yes, sir.
Right? Okay, fine. So I will fill it with a liquid. Okay, and now
yes,
you are telling, well, I will fill it with the liquid, and the meniscus is meniscus of liquid is 0 angle of contact. So you will say this is going to be A, right?
No, sir, that will be 90 degrees.
So you are telling it should be hemispherical. So you are telling it will be like this. You tell me, I will draw. I want to know what is your understanding.
It is, sir, you draw a semicircle, sir.
So that is, I have to draw a hemisphere. That's what you.
Yes.
Right? Okay.
Yes.
I draw a hemisphere. This is sorry.
Sir, draw lower meniscus.
You want me to draw lower meniscus? Right. Okay. Explain.
Sir, since it is a hemisphere, sir, close to the edges, sir, where the water is just meeting the surface.
Okay, that is this point A.
Yes, sir. A and the other point in M as B, sir. In those places, sir, it will be almost parallel to the surface, sir.
Okay, what is parallel? What is parallel?
The liquid surface is almost parallel with very, very small angle that can be neglected, sir. So
you are telling I have to draw a line along this wall here?
Yes, sir, along the wall.
Okay, this is what you want?
Yes, sir.
Okay, right.
And then that will give us 0 angle of contact.
That will give 0 angle of contact.
Yes, sir. At point A, sir. we define that angle of contact in same way, no, sir. Like between the surface of the container and between the surface of the liquid and inside the liquid, the angle. At A, sir, it will be very, very, very close to zero. Sir.
Okay. So you are
Sir, no, sir. That angle, sir, is respect angle, sir. For MSPL, sir, it won't be close to zero.
No, he's right. He's right. It will be close to zero. It will be close to zero.
Sir, but if we take a parabolic shape, sir, it will be more precise, no?
How?
If we take a parabolic shape in that same way.
Parabola
shape will make certain
make some angle. It will not be zero. Hemisphere will make zero. So you are telling the angle of contact is zero. So only for a hemisphere it works.
Yes.
Okay. So what about others? Hello.
Option C.
Option C.
Yes.
If we draw
If a parabola asymptote may be only the one passing vertical. Tangent can be vertical. So you cannot get a parabola.
See, meniscus, when you say meniscus, should it be inside a container only?
Yes, sir. Because adhesive forces are responsible.
No, wait a minute. Supposing I take a glass slab. Okay, then I put a liquid in this glass, I put a drop of water. Then this is going to be this shape. What do you call this? Will you use the word meniscus here?
No, sir. Angle of contact can be defined, but I don't think meniscus will be the right one.
Okay, everybody think.
that will be just a liquid drop.
Liquid drop. I am only seeing 2 or 3 students talking.
Sir, I think meniscus means it has to be in a tube or a container.
Are you sure?
Yes, sir.
Okay, so your friend is right. He's telling meniscus means that. Okay, fine. So the question is now, hemisphere or hemispherical surface or parabolic surface. So the angle of contact, as your friend is telling here, if you take the angle of contact is 0, okay, then yes, he is right. It should be hemispherical in shape. But let us go by the theory now. See, now if you have the surface like this, and if I pour a drop of water, it will just align itself to this shape. I think all of you know this. And if you go by the NCERT textbook, well, you have one force like this, another force like this. I suppose you remember these two. One force vector like this, one force vector like this, another force vector like this, and the third force vector like this. Hello? Hello?
Yes, sir.
So, what is this? What is this? You call this vector as? This is, say, this is glass, and this is water. I hope you remember this. So, this vector is what? Force of this molecule is attracted by air. So, liquid air. What is this vector? This will also be attracted by the glass molecule. So, this will be liquid glass. And what about this vector? This vector will be was liquid. So, this liquid will be attracted by this liquid.
Yes.
Okay. So now in the case of glass water, this will be greater than this. Correct? And therefore the resultant vector will be in this direction. The resultant vector will be in this direction. That is the resultant of these two. And this vector anyway is like this. And so the resultant of all these vectors will be this. Hello? Right? And this vector will be perpendicular to the surface that is here. Okay, I suppose all of you know this theory. Hello, I am asking you. See, in a tube, supposing you have taken water in this tube, okay, a small tube, then you would have got the water surface to be like this, correct? Hello?
Yes, sir. Yes.
How do you go account for this? One is there is a force acting this side, and there is a force downwards, and there is a force like this. I suppose all of you know this. Hello?
Yes.
And the resultant of all these forces, will be what? The resultant of all these forces will be this. And this force will be perpendicular to the surface here. Okay, so that is how you will measure the, that is how you will get to know how the meniscus is and what is this angle, vagera, all those things you know. Right? Okay, so going by that formulation, here in this case, if the shape of the meniscus of the liquid is 0, it is shape of the meniscus of the liquid is 0. That means now, under what condition will that happen? You see, this vector that you see here, right? It is between a force vector of this molecule pulled by the adjacent water molecule. Okay, hello?
Yes.
Now, if the liquid has 0 angle of contact, means, see this red color vector. Okay, this red color vector has 0 angle contact, means what? That means what? That means the liquid at this point must just be, that is, if you draw a tangent to the liquid at this point, the tangent should run along the surface. Clear? Hello?
Yes.
It should run along the surface. That is what your friend is now also telling that. Okay? Okay. Then the meniscus, as your friend is telling, is going to be like this, and the resultant here will be in this direction. No, there is a mistake that I have done in this diagram. See here, the glass is pulling it, the adhesive force is pulling it up. So this is not the vector. I should draw a vector like this. So one vector like this, one vector like this. So here, you see, I'll redraw this. So I filled it with water, assume that I filled it with water. This molecule of water will be attracted by the glass in this direction. Okay, the adhesive force will pull it up. Not the glass, it is the adhesive force will pull it up. Adhesive force means the molecule with air, and here with the glass. Hello? Hello?
Yes.
Then this molecule now will also be attracted by the water. Right? So the resultant of all these things should be in this direction. Then the meniscus will be hemispherical in shape. So under what condition can this happen? Under what condition? See, the only condition is now this molecule is attracted by air, and this molecule is also attracted by the neighboring water molecule, right? And if these two vectors are equal and opposite, they will cancel, and the only vector that will be there is this, and this will become the result. Correct? Okay, and therefore it will be hemispherical in shape. That possibility is there. Okay, anyway, what your friend has given, this one is also right, and in more complicated cases, You should remember that you can also do it with the basics that is given in NCERT textbook, and that is what I have tried to explain.
Understood.
Huh.
So how you can say that if the angle of contact is 0, then the resultant will be?
See, okay, I will do it like this. I will do it like this. Huh? So now I have taken this water drop molecule here. So one vector is in this direction. This is force of liquid with glass, and this is force of liquid with air. Okay? Hello? Hello?
You're considering drop on
Drop on a glass of water. I am considering a drop on a water on a glass. Okay, these two vectors are there. Now the thing is, if supposing the liquid is mercury, then it is going to be like this. Okay, and if it is water, it is going to be like this. So you see, this contact angle. This is what we are telling. This is theta. This is theta. So as the wetting of the glass keeps on decreasing, this angle theta will go on increasing. This angle theta will go on increasing, correct? Okay, so under what circumstance will you have the meniscus of the liquid will be having 0 angle? Under what circumstance? Under what circumstance? Okay, now given a condition for all of you, under what circumstance will the meniscus of the liquid will be 0? I mean, you just tell me in terms of cohesive forces and adhesive forces and all.
Adhesive forces are greater than 12%.
Okay, when adhesive forces are much larger than the cohesive forces. Isn't it? When that dominates. Now, adhesive force between the liquid and the glass or liquid and the air. One of them, correct? One of them. See, this or this. This or this. Okay.
But the liquid and glass is moisture.
No. Okay, one second. Now, the other vector I have to draw is the vector for the liquid, isn't it? Vector for liquid, correct?
Yes, sir.
Now, supposing the vector for liquid is very, very insignificant, very small. For all practical purpose, this is 0. The magnitude is 0. Then one of them, see, if this is larger than this, then the net resultant will be in this direction. Correct?
Yes, sir.
Then and if the net resultant is like this, the liquid has to leave the surface in a hemispherical manner. There is no doubt. Did you understand?
Yes.
See, that is, if you draw, see, now here you see, if I take the liquid surface to be like this, no, at this point I have to draw the resultant vector perpendicular to this point, correct? And the only way this is possible. So what I am trying to explain here is that, so you will have 0 angle contact. That means 0 angle contact, when will you get? Okay, when will that happen? When the adhesive force is much larger than the cohesive force, obviously. Okay, that means this vector is insignificant compared to these vectors.
Sir, but here, sir, the angle of contact is not 0.
Angle of
Contact angle is not 0.
Angle of, see, now if you go by the theory of angle of contact in this case will be what? Angle of contact in this case will be what? It will be 90 degrees. Isn't it? It will be 90 degrees. If you go by this theory, angle of contact here will be 90 degrees. Okay?
Yes,
okay. So therefore now, if you go by that shape, the liquid of 0 angle contact, then this vector I will have to draw it like this, or this. Got it? Okay. In either case, I will get the resultant vector either in this direction. I will get the resultant vector in this direction or this direction. And in either case, the resultant vector is in this direction or this direction. It has to rise like this. That is, the tangent to this point must be perpendicular, and therefore, only hemisphere will support it.
Sir, but here, sir, if the tangent at that point is perpendicular, sir, then then the angle of contact will be 90 degrees. Like we want the situation.
No. This is not the vector I am drawing for a liquid interface. See, listen now. Don't confuse. See, now one vector is in this direction. What is this? This is for a drop on the glass. So what is this vector? Liquid glass. Okay? Hello?
Yes.
Another vector I am going to draw is this. What is this? This is liquid air. Agreed?
Yes.
Now, another vector I am going to draw like this. This is liquid. All of them are on the x-axis.
Yes, sir.
Okay, so the resultant will be along the x-axis. Got it?
Yes.
The resultant will be along the x-axis. Agreed?
Yes.
And the starting point of the liquid must be perpendicular. The surface of the liquid must be perpendicular to the to this resultant vector. And there also you are going to get a hemispherical shape. Okay? Okay? Hello?
Yes.
That is what I am going to do. That is what I am trying to explain here to you is, if I put a drop of the liquid on the glass on the surface, say this is surface, say glass or something, if I put a liquid, will it take the shape of a hemisphere? It is possible, isn't it? And for the same condition, that is possible. Got it?
Yes.
Understood?
Yes.
They are told here the shape of the meniscus of a liquid is 0 angle. Shape of the meniscus? Well, what you are told is correct. It should be in a tube. No doubt about it. But supposing you had put a drop of the liquid on the surface of another surface, okay, and is there a possibility of that being hemispherical in shape? Yes, there is a possibility. Okay, under
Then
whatever I have
the
put.
angle of contact won't be 0 in this case.
It has to be 0.
In a hemispherical
Yes, it has to be 0. This is precisely what I explained now. Then you see, that means now FLG is in this direction, FLA is in this direction, all along the x-axis. FLL is in this direction. Then the resultant has to be along the x-axis, either positive x-axis or negative x-axis. Okay, and then if the resultant is along the x, then the liquid surface must be along the y direction. The tangent to the liquid surface at the point of contact must be along the y axis. Okay, and only possibility is it should be a hemisphere.
But practically speaking, sir, the adhesive forces are more than cohesive forces, sir. Not all the liquid molecules be attracted towards the surface of the glass.
Will be
attracted more towards the surface of the glass than being intact with the molecules of the water.
Okay, so according to you now, say, supposing I put a drop here. So if I put a drop here, then here you see there is air and there is liquid on this side. Okay, so what happens to that molecule? That molecule will be pulled towards this side. See, good question. So this molecule will be pulled towards this side. Hello? Hello?
Yes, sir.
What happens to this molecule? This will also be pulled towards this.
Sir, but
so what happens? So what happens? See, now you have put a drop. The end molecules are being pushed inside, and therefore the center, this molecule, the molecule will start rising in the center. This is precisely what happens. This is precisely what happens, and therefore, see, if you take something and go on compressing, then center it will start increasing.
So why are you taking the liquid glass effect from always towards inside?
Always towards
inside drawing.
Oh, because see now here see this is the theory, man. See, you are taken. Listen here. You are taken. See this. See now, glass also has got surface molecules. Hello, Adil. See, you see. Supposing I take this glass. Okay. Now, what are the molecules that you see? You see one set of molecules here. Okay, these are all glass molecules. Okay, hello?
Yes.
Now, another set of molecules you see here. What are these? Another set of molecules you see here. What are these?
Water.
No, these are, I have not yet put water. These are air molecules.
Okay.
So these are also surface molecules, and these are also surface molecules. Correct?
Okay, sir.
So both are surface molecules. That is, surface molecules means what? A layer. You cannot say it is air or glass. There is one layer of molecules which is, you can take either air or glass or both of them. Correct?
Okay, sir.
And then on this, supposing you pour water. Okay. So the water molecule will also be here. Correct? The water molecules will also be here. So now, if you take one typical molecule here, so the neighboring air molecules will also pull it here. The neighboring glass molecules will also pull it here, and the water molecules will also pull it. See, that surface molecule is pulled by the adjacent molecules: air, glass, and water.
So that glass molecules on the left side also can pull, no?
Left side and right side, both sides. See, in fact, not left side, right side. It will pull on all the directions.
Yes, sir.
It is not just left and right side. It is going to pull on all the directions. Okay, it is a micro arrangement. It's a small micro arrangement. So the angle is not zero there. The angle is very close to zero. So what happens? See, the air molecules, it will slightly pull it like this. The glass molecules will slightly pull it like this. Got it?
Yes.
Okay, and that is how. See, that is why I am telling you that basics what they are given in NCERT textbook, you study that very carefully. Okay, then you will understand these mechanisms. For some more complicated problems, this will be useful to you.
So but in theory which I learned, sir, or theta means greater than less than.
No, don't go to theta. Now don't go to theta. That is a later on abstraction. That's a later on abstraction. Now get to understand these vectors first. Get to understand these vectors first. Okay, a surface molecule, okay, of a drop that you have put, will be attracted by the adjacent molecules. What are the adjacent molecules for it? The glass molecule, the air molecule, and the water molecule.
Yes.
And the resultant of all these three vectors will be always perpendicular to the surface of the meniscus.
So why?
That is the theory. That is what I am trying to explain. That is the theory. Okay. So with that theory only you can solve these problems. Okay. See, now here in this case, the resultant will be in this direction, perpendicular to this tangent. Here, if you take a tangent here, the resultant will be perpendicular. Okay. Anything you take. Okay. That is how it is. And if you take this flat here, the resultant should be perpendicular to this. That is the theory. Now I am just reminding you of the theory. Go in detail. Even in my video, I have given you the detail. If you have difficulties, ask me in the next class. Okay? I spent quite a bit. No, why I have taken up this is because, okay, in this problem it was quite simple. Some other problem it can be difficult. I wanted to draw your attention to the theory that is given in the textbook. The resultant of all the three vectors will be perpendicular to the meniscus. Now listen here very carefully. The resultant of all these three vectors are such that the meniscus will adjust. The surface of the meniscus will adjust. That at the point of contact, the resultant will be perpendicular to the surface. See, gentlemen, now contact force in mechanics you have studied.
Yes.
So the contact force is self-adjusting force. I suppose you recollect that. Okay. So similarly, the meniscus of the surface is self-adjusting. It will adjust in such a way that the surface is perpendicular to the resultant of all these three vectors. Hello, is that clear?
Yes, sir.
So that is what you have to understand very carefully. Done. Shall we proceed?